Okay, I think this is the best quality I'm going to get tonight because I left my document camera at school. So this is 383 Analytic Methods, Part 1. So we're going to look at factoring and simplifying and using the conjugate. So it's 3 strategies to find a limit. Remember that a limit is just a y value of a function that the function is approaching, or it might actually get to that y value. So this says, in a previous adventure, we learned to use substitution when possible. We also learned that substitution does not work at a hole in the graph. There are 3 techniques that can be used to find limits as we approach holes. So this says, note 0 divided by 0 is indeterminate form, because as we approach 0 in the numerator and 0 in the denominator, different things can happen. Later in the course, we will study other indeterminate forms like infinities. So factoring, we've already kind of looked at this strategy. So a hole is referred to as removable discontinuity. When you get to calculus, you're going to focus on continuity. So just getting familiar with some of these terms. You don't have to exactly know what all of these mean yet. This term indicates that we can use algebra to find the y value of the hole. Be aware that in many calculus problems, the c value that x approaches might give us a hint for factoring. So what that's saying is, hey, 3, when I try to plug 3 in, my denominator's undefined. Use that as a hint for how this numerator might factor. What is it that we want to cancel? We want to cancel x minus 3's. Hey, is x minus 3 a factor of this trinomial? Yes, it is. To factor a trinomial, remember you do the diamond method. So I'm going to put 3 in the top of the diamond and -4 in the bottom of the diamond. So reviewing factoring is important for your final exam as well. So what are the factors of 3 that add up to -4? -1 times -3. I take these two as my solutions and my factors. So the numerator is x minus 1 times x minus 3, and the denominator is x minus 3. The x minus 3's cancel. So now I can plug 3 into the new function right there for x. 3 is no longer a problem in the denominator. So I can plug 3 in up here. 3 minus 1 equals 2. So this limit is approaching a hole at the y value of 2. So canceling allows you to just plug that in with substitution. So let's take a look at example 2. Can I plug in 5? Let's see, 25 minus 15 minus 10 is 0 in the denominator. So we need to factor again. The numerator is difference of squares, x plus 5 times x minus 5. How about the denominator? Take your diamond, -10 goes in the top, -3 goes in the bottom. Take a minute and think about the factors of -10. See if you can practice factoring on your own. So what would that be? I need to use 5 and 2. I'm going to need -5, right? Because when I add these together, I get -3. So x minus 5 times x plus 2, the x minus 5's cancel. So that 5 can now be plugged in. 5 plus 5 in the numerator, 5 plus 2 in the denominator gives me 10/7 as my solution, my limit. Okay, in example 3, I can't plug in 0 because I get 0 plus 0 in the denominator. So I'm going to factor the denominator using greatest common factor. What can I pull out of both? X. I'll have x plus 2 left. My numerator was 3x, so this x and this x are single factors and can cancel. I can't factor this x. X plus 2 is stuck together by these parentheses, but I can cancel these x's. So now I have 3 over x plus 2, and I'm allowed to plug in 0 for x. So 3/2 is my solution. So that's just level kind of 1. Factor it, cancel it, plug it in. So now it says, note, sometimes you may need to do some simplifying before factoring. So in example 4, I can't plug in 0. I get 0 in the denominator. I can't factor this yet because it's not been FOILed out. It hasn't been multiplied out. So your first step is to multiply out in the numerator x minus 3 times x minus 3, and then we're going to subtract 9. So I would get x squared minus 3x plus 9, and then there's that minus 9. Well, this adds up to 0. So it looks like my numerator is x squared minus 6x, and then that's all over x. So x times x minus 6 over x, the x's cancel, so that takes away my problem of plugging in 0. So now I can plug in 0, and 0 minus 6 is negative 6. So it's one additional step, and then you're still using that same factoring and canceling. So I like this unit because it helps you review some of your factoring skills. We've reviewed the diamond method, difference of squares, and greatest common factor. All right, example 5, it has h instead of x. You're going to evaluate it the same way. It's just a variable. So we're going to do 7 plus h times 7 plus h first, then subtract 49 to simplify our numerator. So I get 49 plus 7h minus 49. The 49s add up to 0 again. Oops, I forgot my last term, h times h. I missed my h squared term. So yes, the 49s cancel. I forgot my h squared term. So I have 14h plus h squared all over h. So now I can factor out an h, 14 plus h over h. Right, so I took out an h. The h's now cancel. Now I can plug 0 into the equation. And 14 plus 0 is just 14. So that's the idea of simplifying first. So that's strategy number 2 for today. And here is strategy number 3. Using the conjugate. Some of you have taken trig, or all of you have taken trig. So maybe in your trig class you learned that when you have like a radical in the denominator, let's say, you don't have to write this down, but if you had like 1 over root 3 plus 7, to get rid of the radical in the denominator, you would multiply by root 3 minus 7 on top and bottom. So if that looks familiar, that's the conjugate idea. So we're going to use conjugate in a different way. So we cannot plug in 3. 3 minus 3 is 0 again. I can't factor this because of the square root. So the square root is telling you, hey, try this conjugate. A conjugate is you look at the binomial of the radical and then minus this number, and you change it to the radical, so that stays the same, and then put the opposite sign there, so plus the number 2. And you're going to multiply by that conjugate on top and bottom, because multiplying by anything over itself is like multiplying by 1. So now I'm actually going to FOIL out this kind of nasty looking numerator. What is a radical times the same radical? Well, it cancels out the radicals, and you end up with just what is inside, so x plus 1. The nice thing about conjugates is when you do outer and you do inner, you get opposite values that add up to 0. So see how I have 2 of these radicals and I have negative 2 of these radicals? That just added up to 0, so I don't even have to write it down. And then last, negative 2 times 2 is negative 4. That simplifies to, voila, x minus 3 magically. That's what I had in the denominator. So I still have this guy hanging out. I don't want to multiply those together. No, no, no. These so nicely cancel. If you multiplied them together, you couldn't cancel them. When you divide a number by itself, it leaves you with 1. So I have 1 over this, and I want to plug in 3. So I have 1 over the square root of 4 plus 2. 2 plus 2 is 4. So my solution is 1/4. I'm going to do one more example over here. You could pause it and try this example yourself. To do the conjugate, you're going to multiply by the square root of x plus 8 plus 2. Square root x plus 8 plus 2. So I'm going to multiply out and just get x plus 8. My outers plus my inners add up to 0. Negative 2 times 2 is negative 4. That gives me x plus 4 in the numerator. I already had x plus 4 in the denominator. So now my x plus 4's cancel, and I have 1 over the square root of x plus 8 plus 2 left in the denominator. And I want to plug in up here negative 4. So when I plug in negative 4, I get coincidentally the same thing I got in the last problem. I get 1 over the square root of 4 plus 2, which is 1/4. So these aren't always going to come out to 1/4, they just so happen to this time. So now you've got these 6 problems. You've got substitution. This one's going to be factoring first. You've got the conjugate. You've got simplifying and then factoring. So basically the methods that I showed you on this page. So you just need to show me the back page because that's the guided practice for today. Thanks.